ಬಂದಿದ್ಯಾ ಸರ್?
Yes, sir. Perfect, sir.
ಬರೀ ಸ್ಲೈಡ್ ಅಷ್ಟೇ ಕಾಣುತ್ತಲ್ಲ ನಿಮ್ಗೆ? ಈ
Yes, sir,
ಮೇಲ್
only
ಇದೇನೋ
slide.
ಇದೆಯಲ್ಲ ಅದು ಕಾಣುತ್ತಾ?
Sir, logos ಕಾಣುತ್ತೆ ಎಲ್ಲ complete.
ಅಲ್ಲ, ಅದು ಮೋಸ್ಟ್ಲಿ ಅದು ಇದದ್ದು ಅನ್ಸುತ್ತೆ.
Full slide.
ಸ್ಲೈಡ್ ಮಾತ್ರ ಕಾಣುತ್ತೆ ಅಷ್ಟೇ ಅಲ್ಲ ತಾನೆ?
ಹೌದು
ಯಾಕಂದ್ರೆ
ಸರ್, only
ಐ
slide.
ಆಮ್ ನಾಟ್ ಏಬಲ್ ಟು ಸಿ ಬೇರೆಯವ್ರು ಏನ್ ಕಾಣುತ್ತೆ ಅಂತ ನನಗೆ ಗೊತ್ತಾಗ್ತದೆ.
ನೋಡಿ ಸರ್, ಚೇಂಜ್ ಮಾಡಿ ಸರ್ ಸ್ಲೈಡ್. Okay, perfect, sir.
Perfect. Okay, I am ready.
Okay. Very good evening, ಎಲ್ಲರಿಗೂ ಶುಭ ಸಂಜೆ. Welcome to the third session for this talent search webinar series program. Today we have with us Dr. R. Prabhu, Associate Professor, IIT Dharwad, Department of Physics. And I would like to thank Dr. R. Prabhu sir for accepting our invitation to deliver today's session on classical and quantum states. Thank you very much, sir. On behalf of KSTA and on behalf of all the teaching faculty and student fraternity who have joined with us in this YouTube channel as well as WebEx platform, on behalf of all of us, welcome you. Also, I would like to welcome all the teachers and students who will be joining with us shortly and who will be watching this session later. I welcome all of them. Before starting this today's session, I would like to give a brief introduction about R. Prabhu sir. Sir is working as an associate professor in IIT Dharwad, as I said earlier. He is also Associate Dean of Administration and Materials Management Division and a member of Senate. His areas of research interest are quantum information theory, its interface with many body physics and quantum optics, relativistic quantum information, and quantum communication. Apart from that, he has held many academic positions and he has done his PhD from Coimbatore University and postdoctoral fellow from Harishchandra Research Institute, and he is an Inspire faculty in Harishchandra Research Institute, Allahabad, UP, and he has done his postdoctoral fellow from Atom Chip Group from Ben Gurion University of Energy, which is from Israel, and he has worked as assistant professor in Department of Physics, IIT Patna. Later, he joined as assistant professor in IIT Dharwad, in the Department of Physics, and currently working as an associate professor. His academic achievements involved are I would like to mention few here. He is an associate of Indian Academy of Science, Bangalore, and Inspire faculty, and he won the second best presentation in IPS colloquium for young physicists, which was held in Kolkata in the August 2009. Apart from that, he is having many administrative positions held at IIT Dharwad, and he has published many reputed journal papers of repute national and international, and published book chapters. With this brief introduction, I welcome once again R. Prabhu sir, who will be with us today delivering on classical and quantum states. Over to you, sir. Thank you, sir.
Thank you, Umesh ji. So, good evening, all. I would like to express my sincere thanks to KSTA and Dr. Ramesh and as well as Dr. Umesh too for coordinating this particular program. So I am from IIT Dharwad. So let me show you how we are situated in Dharwad. So this is our Suvarna Karnataka. So here comes Hubli, Dharwad twin cities, and Dharwad is a 4 square kilometer area, small town city. So on the outskirts of city, on the sidelines of PB Road, Pune Bengaluru Road, our campus is situated. So, since we are youngest ones, we have an advantage of building new, as per the current technologies as well as current requirements. So we have developed our campus. So here is the sprawling images of our campus. So this is our administrative block, and we have a hostel. So there are 2 hostels of this kind. Each can host almost 1,000 plus students. It is 8-floored building. And then here is KRDC, which is basically library and data center. And here is the CLT, that is Central Lecture Theatre. So this is so much big that in any one given time, so 3,500 students can sit across various rooms or classrooms in this particular building. So, and then here is the academic block. Academic block is basically meant for offices of the faculty and also research labs and so on. And we have a indoor stadium which houses some indoor activities. And here is what is the interior of the CLT, where we have a central dome which allows us ample light, even though it is a circular enclosure. So here is the indoor stadium what we have developed. So we have squash courts and badminton courts, gyms, and swimming pool is also there in the outskirts, outside this indoor stadium, but within the city. And many more facilities are coming up in the due course. So this is just one A phase of the whatever you have seen is just one A phase of the campus. So you can see that here is the administrative block, and there are lab facilities here, and then this is where the lectures will be held. And this is our this one library and two academic blocks, and this is the um, hostel. So this is just a 1 year phase, and then we are soon going to start with a new building. New structures are coming up in very soon. So here is the website drop menu I have captured for you people. So we have BTech. What are the programs that we run is currently BTech. We are having BTech in almost 10 disciplines. So 10 departments are giving BTech programs. So, and we have BSMS program as well, which is a dual degree program. And for both these two programs, the input is through JEE exam, advanced examination. And we have MSc, which is starting from this August onwards, in the physics, chemistry, maths, and biology discipline. And we have MTech programs in certain engineering in engineering as programs. And we have executive MTech as well, like for the people who are working in industry and who want to pursue more um, knowledge accumulation, they will do the executive MTech. And we do have MS as well as PhD program through which we train the students in research activities. And also we take up internship activities, like usually during the semester breaks, people, for our students from other institutes come to us to work on certain research project or try to learn some certain aspects on the interest that they develop in due course of their learnings and so on. So So here is an event which is currently happening, Parsec 5.0, that is fifth version of the Parsec is presently happening in our campus. If any of you are in and around Dharwad, please come and visit, try to register for any event and then try to visit. It gives you an opportunity for you to interact with our students and also know what are their activities, and then some of the students' activities can be explored here. So, since I am talking about the state of a physical system, so I just thought that let me start with what do we understand by physics. So when the physics word comes in front of us, we already know that it is basically a subject, or the subject which deals with the knowledge on the matter or energy or their interactions. So it also helps us to understand the or uncover the how the nature works and how does this universe came into existence and then what it is going to evolve to and then so on. So many questions it can address. So when we look into the physics as a broad area, so we do have several classifications because if one has to get trained in physics means that he cannot do everything. He or she cannot dwell on every aspects of physics. Rather, they try to once they come to some advanced physics courses, they will try to accumulate or try to go in one particular direction in which they can contribute or they can understand more about that particular aspects of physics. So we have mechanics, thermodynamics, sound, electricity and magnetism, and modern physics, which deals with the microscopic world, relativity, and other new theories that have been developed in as we spend our time in this particular kind of environments. So this is an amazing world. So understanding it is very crucial. So if I just pose you a question, like look around. When you look around, what will you see? You will see pen, book, or if you are sitting in a house and then you have a study table, you will see some more material. And of course, you have a screen on which you are seeing the slides. And then if you look around, you will see objects which are hanging on the wall and so on. Like how they are there. Can we describe each and every one of those objects that we see? Okay, so that we'll talk about that means that if you want to describe them, that is the state of that object is what you are considering. Similarly, if you go out of the house, you will see traffic, you will see marvelous monuments or malls and so on, houses and so on. So can you describe their activity, like their existence or their present, future, and so on? Okay, then also you have to describe them like traffic. If you want to describe the what is the state of the lorry or a bike or auto that is running through the streets, or if you want to understand what is the how does this the monuments are came into existence, or what is its present state, whether it is good, depleting, and so on. So and then malls, like how do they work, what is the chaos that is existing there, how many people go there, what is the different things to buy there. So not it's not unique, right? So everything you have to understand means you have to have you have to uncover the state of such system. So if you go to the any country, so country, if you can just consider India as a country, then it has lost vibrant cultures, vibrant people, vibrant languages, and then vibrant way of doing things. So and so on. So, like everything has some description, a specific descriptions are required for these objects or these particular systems. If you go beyond the world Earth, then you have solar system. You know that solar system consists of planets, comets, and asteroids moving around the sun, and then this particular our sun is moving around a center of the galaxy, and so on. So like we have a kind of a basic exposure to you already, but you have to understand that for each and every object, whatever we see or not see, okay, there is a physical description. So this physical description start with the state of that particular physical object. So even if you consider plenty of galaxies that are present in the entire universe, each of them will become like an object for which you have to describe, give a description of the state, and then try to understand whether how it works, how is this existing, what will be its future, and so on. Right. So to get to know that one, you have to understand the state. Okay. So thus, like if you don't know physics, you still can do marvelous things. Okay, so a kid who is playing in the park has inadvertently using the principles of physics, like it comes naturally. Okay, to walk on this kind of a hanging poles, or to spin the top on the ground, or take it take directly into the hand, and put it, hitting the marbles, and then trying to win more marbles as much as possible, are street artists who without any knowledge of any physics, are uncovering how we have to work or do the things. We have adopted that understanding about the state of the objects, how they work, okay, how to win, how to do better activities, and then how to coordinate our body in such a way that we can do well in these kind of activities. So therefore, we have to understand the state of the physical objects in a better way. Okay, can we do a much more better understanding on these things? Then look into the event of just marbles being struck by one single marble. So you know this game, right? You have, like, all of you will, like all of us five friends will chip in some, like, say, four marbles, and then put it into the ground, into the circle, and then start hitting with one single big marble that I will take. And then if you know that the maximum number of marbles that you take out of this circle, you win more. Okay, the strategy goes like this. So you can have a many ways of hitting the marbles. So based on what kind of state of this marble on which you are eyeing, so that you study the state of this marble and then state of the marble on your finger, and then try to hit it. Like when the collision happens, you want the strategy is to get more marbles out, right? Okay, if you are unlucky, then this hit the hitting marble will hit the target. Target will come out, but hitting the source marble will just stuck here. That's also a strategy that is available for you. If your study or understanding about the state of the marble is weak, then you will end up with a sorrow state. But if you are strategically understand the way to hit the marble in a much more better efficient way, then there is a chance that you will win more marbles. So therefore, if you have a basic understanding about the state of the objects, you can do better. Not only winning, you can also perform better. So, like as I was telling, even the farmers who are tilling the like their farmlands, or making a flat bed to sow the paddy fields, they all are using physics understanding that we have inadvertently. Nature has given us a like experience to evolve and then try to make it better. So if you look into the long tills that these farmers do, how nicely they do this parallel tilling of the farmland. And then if you go to some paddy field being developed in the villages, how nice, same smooth, leveled paddy field will be made, so that they can sow the paddies in a much more efficient way. All these things involves physics, but the farmer doesn't know anything about it, but through experience he has gained, either by experience or by study or understanding the through the books. You can uncover more about the how the nature works, or how we can make our life better. Okay, so instead of doing these activities using the ox nowadays, because we understand the things better, the word better, missionaries have been evolved to do these activities, and then perform this activity in a short period, or in a more efficient way, or cost effective way, and so on. Okay, so therefore, state of the physical systems, whether dynamic or static, you have to understand the things. So if you look into these Indian players who come across different different games or different kind of games. So they all have developed their strategies, understanding about the games in such a way that they do better than others, because that's how they have excelled. Okay, so all of us will play cricket, but why Virat Kohli can do better? Because he has a better understanding about the state of the hitting the ball using a bat, or bowling a ball, and so on. Okay, so we have a way to develop by experience or through understanding the physics. So therefore, the basic understanding for us as a students of science should be to understand the state of the physical object. We should have a grip on the state of the physical object so that we can do better, or you can do marvelous things. That should be our target, or by a bird eye view of the state of the physical object. What is state of the physical object? Okay, I would say that it should be a position of the object. You see, so I can put a clock on the wall in any way possible, right? So I do not want to just go take a hammer, nail, and then just hit the wall and then place it. Do you do that one? It's not random, right? You want it to be exactly centered from the both the walls, and also it should be down. It should be little down from the ceiling of the room, and so on. You fix the state, like you fix the coordinates for that particular clock to be hanged on the wall. So that's how you do the you fix the state of that particular clock. Okay, so therefore position takes an important physical identity for the any object, so that you can do well with it. If so, so here is the position. So position are in a three-dimensional coordinates that our eye can capture. Okay, so our eye can describe is good to like is good for describing the three-dimensional system. So therefore, we write the position in terms of three different dimensions, 3D dimensions. But if you ask the ant to do this one, it cannot do. It just ant can see only two-dimensional aspects. So therefore, for each of the position of the food or anything is just description using the two-dimensional surface. So once you have the position, you know that you can make a derivative with respect to time and then get the velocity. Okay, you take a double derivative of the position, you get the acceleration. So once you have the acceleration, you know that our Einstein, sorry, Newton has given a marvelous equation of motion through F is equal to ma. So you can develop this particular equation of motion. Once you have the equation of the motion, then you often any physical object, you have the complete description, or whatever physical quantity later you want. You want a momentum, you want the angular momentum or angular velocity, any physical quantity that you have to get to know about that particular physical system can be obtained. Okay, so therefore I would say that in classical mechanics, so what all the things, the examples that you have seen through experienced and seen are called the classical systems. There the positions will talk about the state of the system, of state of the physical system. So not only state, so the second quantity that you have to be worried about is certain physical quantities associated with that object. Okay, so you have to measure the position, so that hence the position can be calculated. Okay, so then we have length, mass, time, temperature, volume, pressure, specific heat, and other physical quantities that you can think of. Okay, so all these physical quantities which are associated with our classical objects, okay, they are well defined in our textbooks. Okay, we need not to do anything. If you want, if you have a water bottle near you, and then I have also a water bottle here. So if I want to calculate the temperature of this water, and then if you want to calculate the temperature of water in the bottle near you, then you just have to insert a particular thermometer and then get the temperature. Okay, so and it is universal. It doesn't go bad, or it is not, the corrections are not required, and so on. Okay, so the equations that are given to understand this particular physical quantities are well written, and then there is no corrections required, and we can live with that particular understanding. Okay, so now, so if you go to a stronger equations like PV is equal to nRT, which is ideal gas equation, this works. This equation doesn't change if you go from Earth to Moon, or Moon to Sun, or Sun to galaxy, and things like that. Okay, so always this particular equations is constant. So therefore, I have the classical objects which has 2 points. One is state of the system, and the other one is the physical quantities associated with that one. They are all unique. They do not change. They are all well understood. Okay. So once we have such a system, what is this quantum world then? So does the same things happen to the quantum world, or what is quantum world? So quantum world is something which is very microscopic. Okay, can we describe the state of the microscopic world with the exactly similar way of understanding the state of the physical systems in this universe? To understand the state, what will happen in the quantum world, let us try to do an experiment. Okay, so we cannot feel them because it's a microscopic world. I don't know what is happening in the carbon, and then hydrogen, and then oxygen, or the other elements that are on the tip of my finger, which are moving, and then which are becoming molecules, and then which are doing chemical reactions, or which are emitting heat. All these things are happening at the tip of my finger. So there's a lot of things that is physics, chemistry, biology, that is happening at the tip of my finger. Okay, so but I do not feel that one. I don't see that one, but I have an understanding on that one. Okay, so therefore, can I take the understanding of the physical world that I see to the microscopic world is the question. Okay, can I give the same position representation as the state of the microscopic object for an atom? Can I give the same PV is equal to nRT for equation to get the volume or pressure experienced by the atom? So all these things are quite intriguing questions that we have to understand here. So quantum world, whether it is similar to classical world. So to understand this one, I will like people have been using these kind of experiments. So let us try to do an experiment. So now you have a double slit experiment. You all know very well Young's double slit experiment. Okay, if you have two slits here, you have, if you have two slits, then these two slits will give you like a we you know Young's double slit experiment. I need not to go to the nitty gritty of that. The things that they will be like very close to each other when compared to the wavelength and other aspects. So you put a light here, and then you have a two slit. Okay, so as soon as light is switched on, then there is a wavefronts that are developed on the at each of this particular slit, and these wavefronts are secondary wavefronts which try to interfere among themselves and then give a nice interference pattern on the screen. Okay, so to understand this one, you can just look into this particular experiment of the waves on the water. So you have a primary waves here, which are coming and hitting the two slits, and then secondary wavelets are formed, and these wavelets are giving you bright and dark spots. So wherever the bright interference happens, and then we have constructive interference, then we have a bright spot, and wherever there is a destructive interference happens, there we have the dark spot. So hence we have a beautiful interference pattern on the screen. So now I will put away the particular experiment and then make a 180-degree rotation, and then start pouring some sand on this particular double slit. The sand is made up of particles, okay, all fine grains of earthy material. So you pour it. When you pour it, you will see that you don't see any kind of a interference or anything. There is nothing like similar to the behavior of light, but you see two separate heaps which are two different for which the peak is at the closest point to the each of the slits. Okay, so there is two heaps created, and there is nothing to so special about this one. There is no alternative heaps or shallow regions developed here. Okay, this is a quite straightforward understanding of what will happen when I do the double slit experiment with the sand or with the particles. Now, these are all classical things. Now, let us replace such a system by atoms. Okay, so here is a atom gun which is sending each like atoms through it's one of its outgoing outlet, and then these atoms are coming and hitting these two slits that are there, and I close one of the slit. Okay, deliberately. So what happens is that whatever the atoms that come and hit the slit or go through this slit, they will come and hit the screen, which is kind of a recorder. It can be a photographic plate in your case. So now you will see some kind of a heap that is developed. It is like it is just similar to what we have seen. If we close this particular one of the slit, okay, if we close this one, the other one is open. This is what exactly we see. The intensity will get accumulated near to this particular open slit. But if you open both of them and then send the atoms slowly, okay, so you are sending the atoms, and then these atoms can go to any one of these two slits. So you will start seeing that the recorder or the photographic plate getting some readings over there. You leave it to quite long time. The exposure should be for long time. When you leave it for the long time, what you will see is that you are seeing these are the atoms, which are single particles which are coming out of this particular source. Okay, just like a sand, each of the grain is coming on these particular two slits. But when you see the a photographic plate, then you will see that there is a concentrated concentration of the intensity or the atoms being concentrated at a regular patterns, which gives you an impression that the atoms have interfered among themselves to give you the interference pattern. Remember, rather than seeing that it's just the atoms or single entities which are coming through this particular atom gun, but I'm seeing the interference pattern. That is, like atoms, are they behaving like a particle? But they were supposed to behave like a particle, but rather they are exhibiting the wave-like behavior. So now we have, since we have seen the interference, so let us try to understand this one. Let us see what is happening in that experiment. So to see, I'll put a laser light here so that I understand when an atom, single atom comes from the atom gun, in which path it has gone. Okay, I know since I switch on this laser light, that laser light will change the atom so that I see whether the atom came in the first path or in the second path. Okay, so if I do this experiment, okay, I didn't do anything. I just put a laser light into the system. Okay, if I do that one, exactly what these atoms, which are kind of a lumps of the entities, like grains of the sand, they were coming. Now, as soon as you place a laser, to look at the how in which path they have gone, then you'll see the behavior like a like a particles. So there is no interference anymore. Just because you place the laser light, there is no interference. So what happened? So now let us switch off the laser light again. Okay, there is no observation. There is no looking through which atoms in which path they went. So now again, as soon as I switch on the same setup, same equipment, I don't change any atom gun or anything, or the sources or the double slit and so on. Just turn off the laser light, you'll see the interference pattern. So when you switch off the laser light, to understand which path that particular each and every atom has gone through, you will see interference. That is, the atoms behaved like the wave, but when you switch on, you don't see the interference. Rather, the atoms now behaved like a particle. So how do we understand this one? How can it be, right? So it's kind of a surprising behavior that is exhibited by the atoms. So what happened in this? What is happening in the quantum world? So when I observe the electron or the atoms are behaving like the particles, when I don't see, they show the interference pattern. So how do we understand the state of this particular atoms? Okay, so let us try to do that one. If you have an atom, okay, so you know that. Oh, sorry. So if you want to understand an atom, all of you are well adversed with the structure of the atom. So it consists of a nucleus and then electron revolving around that particular nucleus. If it is hydrogen, then you have single electron, so it keeps revolving around the nucleus. But this is the stable orbital of that particular electron in an atom. But if I give you more energy for this particular electron, okay, you know that this electron can come to the higher energy levels, right? Same single electron is there, neutron, the nucleus is there, and then there is there is this particular electron which jumps to higher energy levels depending on the whatever the amount of energy that you give. Okay, but still hydrogen single electron atom is what you have. Okay, so that's what is an understanding of an atom. What is this energy state? So these are steady energy levels. Depending on the energy, the electron can be in this ground state, say call it as a ground state, first excited state, second excited state, and so on. Okay, so this is the way we have understood the structure of an atom. Okay, if there are two electrons, then the electrons can be here, for ground state, first excited state, or first excited state, second excited state, depending on whatever the energy that you provide to the atom. That particular atom can be in the put to place. These two electrons can be put into any energy level within an atom. Okay, so that's what is the understanding that you have, right? So let's try to work it out. Now, if I have the electron in the ground state, single electron of this atom in the ground state, which is revolving around a given steady state, then I call it as the state of that particular electron as the psi naught. Since I have only one electron, this can also be the state of an atom. There is no problem to analogically interchange the state of an atom or electron. Okay, it's the same description. So now, though if you provide more energy, the electron can go to the first excited state or the second excited state, and so on. If you more and more energy, the electron can jump to the higher energy levels, and hence it can, at some point, if you give the ionization energy, then this electron will come out. Okay, remember, all these intermediate energy levels are still available for the electron. They don't vanish. Okay, so therefore, if I want to write the wave function or the state of an atom, then it should be a superposition of some energy, some wave function which has some energy, E0 energy, ground state energy, so a wave function corresponding to the first excited state and which has energy E1, and second excited state wave function which has energy when the particular electron can acquire energy E2, and so on. So you add all the possible energy levels that you can allow this atom can possess. Okay, so then if you sum all these allowed, like this is a superimposition. Do not consider I have a three electron atom here. It is like a superposition of ground state, first excited state, second excited state, so on, so on. Okay. So if you take all the possible energy levels which comes with certain energies, okay, so you add them, then this will give you the total state of the atom. Okay, this total state of the atom is described with like this. Okay, summation over I 0 to n Ci psi I, where summation over Ci is will capture the probability of the electron being in the ground state, probability of electron being in the first excited state, probability of being in the second excited state, and so on. So there are several probabilities. N plus 1 probabilities are available here. Okay, so therefore, but this atom is existing and it has only one electron. In which particular energy level it particular electron has is not known to me. So therefore, the total energy is just considered written like this, and Ci's should sum up to 1. That means the probabilities with which this particular three or more atomic structures are possible, they all should sum up to 1, because there is a true atom with a single electron. Okay, so therefore you have this wave function defined for an atom. Now this is the general understanding of the quantum state for any quantum particle. Now I just consider two level system, a ground state and first excited state. Okay, if I do that one, that means that all the energy levels are there, but I have sufficient energy to keep this electron in an atom either in the ground state or first excited state. Okay, if I do that one, the allowed energy levels for this particular atom in an electron in an atom is either ground state or the first excited state. So therefore, the total wave function of this atom can be written as, or this particular microscopic object can be written as C naught psi 0 or plus C1 psi 1, such a way that the probability of finding the electron in the ground state plus probability of finding the electron in the excited state will add up to 1. Okay, either this electron should be in the ground state or in the first excited state. So that's why the total wave function is written like this. When we have like this kind of system, two level systems, they can be written as like 0 and 1 state. Okay, so 0 is basically ground state, and then 1 is in the first excited state. Or if you want two allowed state of the electron can be upspin and downspin, right? So you can have upspin and downspin, you can call 0 and 1. If you take a photon, the horizontal and vertical polarizations can be called as the two possible states for the photon, and so on. So you can exploit the available two level systems. So all these things can be represented by 0 and 1, and this is what is called the qubit. Okay, so these two levels of an atom, or an electron which is upspin and downspin, or a photon which is horizontal and vertical spin, those are the two allowed states for those objects. Okay, microscopic objects. Such systems which has total wave function having two possible states are called qubits. So this is what is the basic entity for the quantum computation. Okay, so now let's not get into the properties and things like that. Now if I take a three level atom, okay, you have an atom in which an electron can stay in 0 ground state or first excited state or second excited state, then again the total wave function of such an atom is probability of finding that particular electron in the psi naught, probability of finding the electron in the psi 1, or probability of finding the particle in the second excited state. Okay, so there are three possibilities that are possible, and total wave function is written like this. And then we have this wave function, total wave function. When you observe, you will collapse into any one of these. Okay, when you don't see the atom, you have probability of finding the particle in an ground state, probability of finding in the of an electron in the first excited state, or probability of finding the electron in the second excited state. Three possible states are there, but when you see, then it will only one of them should appear. It will collapse. The entire wave function will collapse into one of the state. So such three-level systems are called quitted. Okay, so similarly, if you keep on extending the number of energy levels that are allowed to the electron in an atom to more and more, you will go or keep on extending your total wave functions to more number of terms in such a way that when you take these terms, the weights that are associated here, they add up to one all the time. That means the electron is present, and if you try to measure that, okay, that should collapse to any one of these states. Okay, this is a different atom, this is a different atom, this is a different atom. Okay, so but if you try to make a measurement on any of these such atoms, the possible states that will come out is psi naught, psi 1, psi 2, psi 3. Here there is three possibilities, here there are two possibilities, and if you increase more possible state, allowed state, then you have more states that are feasible. So now let us try to understand what is the double slit experiment. How seeing an atom and not seeing an atom, how does it change the scenario? Okay, when you look at it, okay, so this is the input state. The state is two-level system. Say for example, electron is in the either ground state or in the excited state. You have just consider two-level system for the basic simple understanding. Okay, so now, excuse me. So now once you have this two-level system, you are sending n number of particles. There are n number of two-level systems that are incident on this one. And when you make an observation, okay, it's no more a superposition of 0 and 1. It's no more a qubit of two possible states. You are rather, when you take an electron incident on this one to observe what kind of, you are revealing the atom is in the ground state or excited state, both in the A slit or in the B slit. And hence, you have clear understanding of these particles. The grains of the particles are well known to you, and hence they are like behaving like a particles, and hence you will get an ensemble of 0A or 0B or 1A or 1B, or the state of the atoms that are coming here, and hence these behave like a particle. But when you consider the same two-level atom, okay, and you are switched off the laser light, so therefore each and every atom that come through this slit A or slit B is in this superposition state. Okay, so then you have the probability of finding the particle in the zero state or in the excited ground state or excited state, or here also ground state and excited state. There is a wave interference of these probabilities of getting these particular states in 0 and 1, and hence this ensemble will look like it is the superposition of the two atoms which are kind of available in the superposition state. They are interfering with themselves. Okay, so therefore you see the wave-like nature when you don't observe the atoms in which path they have gone, whether A path or B path. If you don't have that knowledge, then there is these atoms that will pass through from the slit to this screen. They are in the superposition state, so they can interfere among themselves to give this particular kind of the pattern. So thus, if you see an atom, okay, it will show a different face to you. When you don't see, it will behave differently. Okay, that's what is the quantum state means. So the in quantum mechanics, if you want to understand what is the state of a quantum system, the quantum system is captured by the wave function. That is, it is like if you have a free particle, which is a free quantum particle, which is moving in the space, then it resembles like a equation of the, if you write a equation for the, it resembles like a equation of a plane wave. Okay, if you have an atom which is like a two-level atom, then it looks like you have two levels are allowed for you, and you will have two levels, which will be the total wave function is just a qubit, is what we call. Okay, and not only this one, when we try to measure the physical quantities, okay, that are associated with these quantum systems, they are not unique. Okay, they have different, depending on their environment, we have different kind of understanding of such physical quantity or physical states. Okay, and also they not only the wave function writing the state of the physical system, they also come up with a strange kind of like exhibition of their physical quantities relations. Okay, for example, if you have a position, you cannot kind the position of the quantum particle without altering its momentum. Okay, so if there is a car moving on the in the road, you can fix the position and then you can fix the momentum for that car. Okay, but if you try to do such thing, it doesn't do well with the microscopic particle. Microscopic particles description is quite different than the classical word. The classical word state is well defined, like you can know what is the three-dimensional coordinates and then you can get it. But in the quantum world, we do not have a description of like when you try to give a description, you are observing, then it shows something like a particle behavior. But when you don't see it, it will show a different behavior, altogether different behavior. So hence there is a kind of a understanding, like for us, the people have evolved the quantum understanding and quantum world in a particular direction for last one almost 100 years, 100 years plus, almost 120 years. This quantum world understanding of quantum world has evolved in one particular direction, and hence we have a quantum mechanics where it is completely different from the our understanding of the word or what we called as a classical word. Okay, so quantum world will give the descriptions on the quantum systems. Here the state of the quantum systems are different, and the properties, physical properties that you try to calculate for these particular systems will also be different depending on the kind of the system that you have and things like that. Here, the equation of motion is basically the Schrodinger equation, which is basically a relation as this is the energy expression, this is the momentum expression, this is the potential expression. There is this is E is equal to T plus V, or energy is equal to kinetic energy plus potential energy. This is the same energy expression that is there in the classical world, but written in a different way for the quantum systems. And here also it is a three-dimensional coordinates plus three-dimensional coordinates, and depending on the kind of quantum systems, these equations can be written. Okay, so thus the quantum world is quite different. So basic understanding about the state of the physical world that we are living in is consists of two kinds. One is classical state, which basically is a position of the classical systems. It can go from the observational particles which can be seen from our naked eye to the celestial objects. But the quantum world is quite different. The state of the quantum world is the wave function, and it reveals itself when you look at it in a different way and when you don't look at it in another quite completely unorthodox way of looking at it. Okay, the influence of looking at it will put you into two different categories. If you look, they behave differently. If you don't look, we have to understand them as a different exhibiting different behavior. So now the entire technology that is quantum technology that is developing today is through not interfering with the system, rather try to understand how to exploit it by leaving it to itself without observation. Okay, so therefore you have a plethora of advantage of using the quantum systems in the technology development that is existing in this particular that is coming up in your lifetime. You will experience all the quantum advantages that is getting developed as of now. Okay, so thus this is what is Einstein's problem of understanding the quantum mechanics. Like if I see the moon, like in the classical sense, moon exists, right? If I don't see, it doesn't mean that moon has vanished. It is still there. Okay, so when I see some object, it means realistically classical sense, in classical sense, even when I don't see that existence of that particle is there. But in quantum mechanics it doesn't happen like that. When you see, the quantum state will collapse to any one of those particular superposition state. But when you don't see, the probability of finding the particle in any of the allowed energy levels is still there, and hence the behavior of the quantum particles when you see and when you don't see is quite different. So that's what we are trying to exploit upon. So I have been asked to also give you insights into careers in physics. So therefore, I have done one small this one flow chart here. So since most of you are doing +2, so and you are writing some competitive exams to get into some professional courses. So for those who want to build a career in physics, these are the three things. You can do BSc or take BSMS courses or BTech courses in any state university, central universities. And if you want to really get into some good environment, then you have to consider getting into IAC or research institutes or IITs or ISS. And also other possibilities is that like you can get into NITs as well. So, like once you do get into such places, you can exit. Like you can take your undergraduate or dual degrees, and then exit to get into some job. Like you can get into industries, IT, BT, and so on, and then you can get into bank, and then also some UPSC and state civil services and national civil services examinations you can take, or you can work in NGOs and other arenas will open up if you enter into this line. But if you want to do career in physics, then after doing your undergraduate or while doing your undergraduate, you have to explore how to become more knowledgeable in physics by doing internships, by getting in contact with the people who are doing research either in IITs or ISS or some research institutions like IRRI, IIA, and IMSC and other many a lot of TIFR and other lot of research institutions are available for you where you can go and try to do internships and then try to explore what will people do. Usually after your undergraduate or postgraduate, you can get into a PhD program. Usually, people in good institutions like IITs or ISS or IAC or other places, so central universities also. So they try to do their UG, PGs to the depending on the courses they have gone. So they try to clear some competitive examinations within India, like UGC or just joint entrance screening test, which is done by the IAC and other research institutes, dedicated research institutions in India. And GATE will give you eligibility to get to do PhD in IITs, and Inspire Fellowship can make you eligible to get into PhD program anywhere across India. So either you can write these Indian competitive exams and get into the research institutions like IITs, NITs, ISS, as well as central universities and other places, research institutions. Or they will, usually our students will also try to write some common English efficiency tests, and along with that one, they try to take some this one like interviews direct admission into the some universities in abroad to do MS or PhD. So either they get into PhD program, okay, or they try to do MS and then PhD. So that they do their masters and again one more masters in abroad and then try to do PhD. And after achieving PhD, either in India or abroad, people try to do postdoc. So this is called a phase after PhD where you go to a different group and then try to do more research activity and then gain more knowledge on the topics that you have been working upon. This can happen in India and abroad again. So usually in Indian scenario, we try to go abroad to do postdoc. So, for example, when Umesh ji introduced me, he told that I spent some time in Ben Gurion University of Negev in Israel. So I went there to do postdoc. So, but before that, after PhD, also I try to do some work in India. It's within India. So, but usually the people who come to these good institutions like IAC, TF, or IITs and other research institutions and ISS, so they all go to do postdoc abroad. They do some ample time, spend time, ample amount of time as a postdoc in abroad, and then they try, some of them they try to get positions in abroad, or some of them they come back to these research like a higher level higher education institutes of national importance and then try to settle down. And they will here like people like us in IITs, ISS and IAC and faculty who are here, we try to do both teaching as well as research. Okay, so like we do train our PhD students and then we try to do uncover more physics through our basic research capabilities. So when it comes to career in physics, there are two ways. One is theoretical, one is experimental. You have to start looking into those directions. Like what is your interest? Like as I told you, physics is subdivided into many disciplines. You have to understand like what is your interest. So once you get into undergraduate program, you will get to know what you have to do, and you have to start discussing with the faculty in the undergraduate programs, where you have to see try to do internships between the semester gaps, and hence you can start getting exposure to the all these career opportunities that is available in physics. Okay, so thank you very much for your kind attention, and thanks for the opportunity to give some insights on classical state and the quantum state and what is the difference between them. Thank you very much. I am ready to take up some questions if there are any questions.
Thank you very much, sir. If any other questions from the participants, either in the YouTube, they can mention in the chat box, or they can give a virtual signal so that I can unmute them. Sir, how students can apply for internship in IIT Dharwad?
Usually, the existing students who are in ISIS, ISIS or other IITs and NITs and so on, they usually write a mail to faculty. So there are two ways to get into internship. One is write a mail to desired faculty. Like somebody likes to work with me, my research field, they like it. Then they will write to me and then ask, can I come for the internship? So it so happens that yeah, I may have a private this one funding. We usually write research projects to DST and other research funding agencies. There is a component where you have to take some social responsibilities. Under that one, we can give some fellowship to the intern students, like 5,000 per month we give to the student, and they can spend 2 months in our institutions. That is one direction. Like faculty themselves, they can fund the intern student. And the other one is that in our institute, per faculty, they will fund one intern student. Again, they will give 5,000. So that we will open a portal in which they have to apply. Usually, I suggest that you write to the people with whom you have to work and then wait for them to respond. Okay, throughout the year we keep getting, and then we don't do scrutiny yeah, as and when the applications come. So what we try to do is that we usually take some time when the time is appropriate. We will scrutinize and then call the students to come directly.
Thank
And
you so
another
much.
thing is that if you are, say, for example, nearby institutes like Bangalore, you can stay at home and then go to a research lab, try to work there as a day scholar, and then come back. Then I don't think there is a funding requirement. In such cases, you will be called by the faculty to work directly under you, but that won't that will give you may allow you to take a letter of recommendations in the later stages when you apply to do PhD postdocs, PhD, especially PhD in abroad. You have to send also supplement with letter of recommendations. In that cases, it will help. But you'll not get certificate, but it is nonetheless you can still put it in your CV, like in your biodata or resume, to say that I have worked on that particular topic under that particular guidance. So that's how the yeah, that kind of contacts will also help you. And another important thing that I want to shed light here is that usually when you're doing when our students when they are doing undergraduate programs, they try to publish papers, research articles. So these research articles will have weighted their own weightage when you apply to do PhD abroad. So usually ISS and IIT students, they try to get a paper by working with their existing their own institute faculty, or going and doing internship elsewhere, and then try to do rigorously. They will work day and night. They put a lot of effort to get publications so that their path to get into PhD programs in good institutions will be clear.
Thank you very much, sir. Any other questions or any doubts? Mr. Yamnappa, Ms. Meghna, PB Suhana, and Ambika. If you want to ask any questions directly to sir, I will unmute you. Otherwise, we will end up the session. If in case you come across any doubts or you need any clarifications related to the subject or any career guidance, you can reach out to us through email or through the group we have created, or through the call. We will connect to sir and will try to give you the solution or best answer for your questions. Is that okay, sir?
Yes, absolutely fine. You can always write to me. There is no this one. So, moreover, I am from Karnataka. So, being a Kannadiga, I will be very happy to put a try to
Thank,
give more time and this some guidance requirements. What as per the your this one.
thank you very much, sir. And I request students who stay nearby Dharwad, they can visit IIT Dharwad Tech Fest, and you will get some exposure about the events and about IIT, how that college has many disciplines, departments, and it will be very helpful for your future.
Yeah, you can
Environment.
also not only that one, you can also come to
Yeah,
like write to me and then try to see whether you want to visit our labs and things like that. Just write to me because you need a entry this one permissions. So and also it is on the outskirts. So if you come in your own vehicle, you have to leave it outside, and then the security will be there so that if you want to enter means you need some kind of a contact this. So
yes, sir.
write
Yes,
to
sir.
me, I will allow I'll see when you can come, like mutually convenient time we can call
Sure,
you
sir.
up and then discuss on the thing,
Thank you,
and
thank you,
also
thank
allow
you very
you
much.
to go around in the research labs to
Sir, any open day kind of thing happens in IIT Dharwad once in
as
a
of
year?
now, no. So probably we will plan sometime some things in the later stages.
Okay, sir. Okay, sir. So that on that day itself, all the
No,
students.
if any students is really interested to walk around the campus, I will be very happy to host you here and then take you around. So that's not an issue.
Sure, sir. Thank you, sir. I request students who would like to visit IIT Dharwad, they can reach out to us in a group of some students and faculty, and we'll make some arrangements
Yeah, if there are some institutions, like you can also ask your institutions to come over. Just let me know, because we have outreach activity cell as well, and then also public relations officers is also there. I'll put you in touch. If at all you plan to come in group, I can put you in touch with them, so that they will take care of doing some like some sessions and things like that. Usually, students from schools and institutions from other districts also come to Dharwad to see IIT Dharwad, and then we have a sessions for those things as well. So there is some outreach component in our this one. We will be able to host you all if you come in a group.
Thank you, sir. It will be really helpful for few of the participants. They are mentioned in the chat box, and sure they will try to visit once IIT Dharwad in future.
Sure. You're ಎಲ್ಲರಿಗೂ
Yes.
like I will be open to invite you all. So, and another thing, is there any questions in the YouTube? I see
Yes.
opening.
No, sorry. When I checked, it was not there. Just let me check once again. No, sir. There also we have not received any questions.
Queries are not there. Okay, then.
Queries are not there, sir. Queries are not there.
Please be open. So you should
Yes,
be more. Don't hinder your thoughts on anything with people like us. So we will be very happy to discuss more on any aspects, not only this one. So don't hesitate.
yes.
We are not like an unhuman people. So we are also humans. So you can always openly ask whatever you feel like. Okay.
Thank you, sir. We'll wind up now the session formally. Before that,
Thank
I
you
would
very
like
much
to
for
thank
having
you.
me here, Umesh ji,
Thank you,
and
sir. Thank
also
you for
Public
delivering
Service Dharwad.
such an insightful and engaging session, sir. Your expertise and passion truly made this topic come to life, and I appreciate the time and effort you have put into preparing and sharing your knowledge, sir. Also, and
Thank you so
prepare
much. It's my
participants for
duty for these people who have really got into these talent search competitive exams, and
yes,
I congratulate you all. So try to try to do well in your life and then careers. Okay.
yes.
So I wish you all, everybody here, all the best. Thank you.
Thank you, sir. Thank you very much, sir. Also, I would like to thank all the participants who have joined today with this WebEx platform as well as YouTube channel. Please contact us and reach us if you come across any doubts and related to subject and any career guidance. We will try to bridge the gap between you and the needy thing. Thank you. Thank you once again.
Yeah. So Umesh sir, so I can exit as well, right?
Yes, sir. Meanwhile, regarding that policy paper, sir has